Right, so, and this is what it would look like, if you looked at the karyotype of an individual that had Down syndrome, you can see here that there is that extra chromosome. So more is not always better, unfortunately. All right, so let's take a look, and again, looking at pedigrees, they'll give you information. You have to identify, okay, what is the dominant trait and what's the recessive? And then what do I see? Do I see the dominant? Then that's going to be homozygous. If I see that the person actually is afflicted by the syndrome or the trait, then it's probably going to be homozygous recessive. And then if they're just a carrier, then it always means that they are heterozygous. So that's the first thing you have to do, is make sure that you are correctly identifying everything. So it says, what are the chances, third generation allele, so this would be the third generation, but we call this the F1 and this is the F2, right? So F1, and then here we have F2, has a child affected by color blindness if she marries a colorblind male. All right, so based on this information, I need to look at my key. So colorblind male, normal vision male, normal vision female, normal vision female with recessive gene. So basically, this is, obviously, is this going to be heterozygous or homozygous?
Hetero.
Good, going to be hetero. All of these are going to be homozygous, but is this one going to be recessive if it's colorblind, or is it going to be dominant?
Dominant.
Okay, who likes dominant? Who likes recessive? Yeah, the majority of people are not colorblind. And so we would call this, what letter do you guys want to use? Want to do N's for normal or
B.
B for blind? Okay, B's are better than N's probably anyway. So if we're saying colorblind is the recessive, then we know this is a person who's little b, right? Normal vision, saying, oops, that this person, it's not a carrier, so we know that it would just be the homozygous and it's dominant because it's normal vision. Normal vision female, again, would be the two bigs. And then this would be, you told me, heterozygous. So now that you have your coloring and your shading identified based on genotypes with our alleles, we can take a look at Allie here, right? And we know that she's going to be big B, little b, right? And so it says if she marries a colorblind male. So we know that he's going to be little b, little b. So looking at this problem, it kind of looks overwhelming at first, but if you just start like slowly breaking it down, you know, it usually is not too bad. So now we just make a Punnett square and fill in those genotypes. So we can put Allie here. Would it be okay if we put her at the top?
Yeah.
Yeah, that'd be no problem. It doesn't matter, but one letter from each parent goes at the top, one letter for each parent goes on the side, and now we cross it over. The big B comes over, the little b comes down. Little b over, little b down. Big B over, little b down, and little b over, little b down. So, back to the question, it says, what are the chances that she will have a child affected by color blindness? So what genotype do you need to be looking for to see a colorblind offspring phenotype, Sarah? Which sizes? Little b, little b. So as I look at this, I see how many? 9?
I think you messed up.
Did I mess up?
Key, yep, on the key says
What?
big B for yellow square. But you wrote.
Oh, normal vision.
Yeah.
It's asking for a colorblind man.
Yeah.
But in the chart.
Oh.
I thought that was just saying like a hypothetical. Like what would happen
I'm so confused.
Okay, so either we go with what's here. I was going off of the words. Let's go off of the words, I guess. Or which way do you guys want to do it? Because either way, like, it's just,
if
the words do make more sense. Yeah, so this should need to be orange, right?
I'll just shoot it down.
Yeah, so let's just write in here orange. Yikes, sorry. Good catch there. Yeah, I was going off the words for sure. Not the colors. And so really, like, if you had done it based on the normal vision, then obviously none of the offspring would be, but if you go with the actual question, then we're looking at this percentage. So yeah, let's make this orange to match the words. Since you guys don't really have very good color on your paper anyway, so, good. Okay, thank you for pointing that out. All right, so back to the percentages. Sarah told us that the offspring to show color blindness as the phenotype would have to have a genotype that is homozygous recessive. How many homozygous recessives out of 4 do you see there? What do you see, Haley? How many homozygous recessives do you see? 2. So 2 out of 4 is going to be 50%. Right? And so really, the thing with pedigrees is just making sure, well, hopefully they're not giving you conflicting information for one thing. And the other is, you know, just making sure you're picking out, okay, what's dominant? Is that normal vision or is that color blindness? And then making, obviously, capital go with the dominant, lowercase go with the recessive. And then picking out, is it homozygous dominant or is it homozygous recessive, or is the trait, or is the individual showing heterozygous? Right, that's the hardest part with it. Setting up the Punnett square from there is easy. Yes?
Quick question. How
Yeah.
did the F1 generation be colorblind?
Yeah, so I'm not sure if they have, I need to switch because really this shouldn't be able to be colorblind based on that. It's almost like they have it switched. I don't know. So I need to take a look. Yeah. Yes, I will need you to do the sign out. Leave your phone if you have it. Yeah, after you said that, I was looking, I'm like, that doesn't, yes, please, just do it. Yeah. I need to take a look at that, and I'll try to find a better example that actually could be